welcome to Bangor Christian Schools. This is AP Calculus. Zach, we're praying for you. Ralph, why are you skipping school today? No, I'm just kidding. All right, so we're in 4.4, and we're going to learn how to take the derivative of an exponential function. And so what we want to do is we want to figure out what is the derivative of a to the x power. Any takers on this question? If I want to figure out the derivative of a function which I have not differentiated before, what do I have to do? Difference quotient. That's exactly right. So this is the limit as h goes to 0 of a to the x plus h minus a to the x all over h. And that's where it all begins. That's where it all begins. And I'll tell you what, guys, let's try something different today. I'm going to leave this in your hands. If you want to today, to just put your pencils and pens down, and as I do things on the board, you can, and then you can watch the video on YouTube later and get notes from that. If you want to do that, you can, but you don't have to. We're going to give it a try one time, okay? So, can I convince you that this is equal to the limit as h goes to 0 of a to the x times a to the h minus 1 all over h? Can I convince you that that's true? What is a to the x plus h? That's a to the x times a to the h, right? So what I'm literally doing here is I'm factoring out an a to the x. And the limit is as h goes to 0. So does the limit affect this term at all? It doesn't. So what happens is this becomes a to the x times the limit as h goes to 0 of a to the h minus 1. I need to write it correctly first. A to the h, then minus 1 all over h. And this part right here, the limit, turns out to be the natural log of a by taking that limit. So what we're ending up with here is a to the x times natural log of a. And that is the derivative of the function. Okay? So let's look at a couple examples here. Example. What is the derivative of 2 to the x power? Well, it's 2 to the x times natural log 2. Done. What is the derivative of 3 to the 5x plus 2? Well, remember we're going to have to use the chain rule to make this work, right? So this becomes 3 to the 5x plus 2 times natural log 3 times, by the chain rule, what's the derivative of 5x plus 2? 5. So what you have to do here, Jacob, is you have to say 5 natural log 3 times 3 to the 5x plus 2. And you can't multiply this 5 here and this 3. You can't. Why can't you? Why can't you multiply this 5 here and this 3? Because what is the power of this 3? It's 5x plus 2. So these numbers can't be multiplied, so that's as far as we can go. Okay? So the chain rule still applies. Okay? What is the derivative of 5 to the x squared? What is the derivative of 5 to the x squared? Well, according to the rule, it's 5 to the x squared times natural log 5. But now what does the chain rule say I have to take the derivative of next? X squared, which is what? 2x. So now this becomes 2x natural log 5 times 5 to the x squared. How are we doing so far? What is the derivative of 1/3 to the 2x minus 5. I'll give you a minute. Go ahead and see if you can do that one. The derivative of 1/3 to the 2x minus 5. Okay, you should get 2 natural log 1/3 times 1/3 to the 2x minus 5. What you get? Yes, ma'am.
All right. How do you do that very last part, the 1/3 times 2 to the x? I understand how to do it, but why?
How to do it, but why? Okay, let's just go back to the rule. If I take the derivative of a to, I'm going to say a raised to another function, then by the rule, this becomes a to the function times natural log a times f prime by the chain rule. Well, okay, what is this right here? This is 1/3 raised to the 2x minus 5. So I can actually start with this part right here, Tori. 1/3 to the 2x minus 5, then times natural log of 1/3, then times, what is the derivative of that function, 2x minus 5? Well, it's 2. So I've rearranged it now because multiplication lets me, 2 times 3 is the same thing as 3 times 2. So 2 times natural log of 1/3 is the same thing as natural log of 1/3 times 2. I can rearrange things now because it's all multiplied. That's why I'm doing that. Does that kind of answer your question? Okay. All right. The power rule still applies. Still have to use the power rule. What is the derivative of 3 to the 5x squared? Okay. What is the outer function here? The outer function here. It's the square. So the power rule has to come first. So this becomes 2 to the 3 5x to the 1. Now times the derivative of 3 to the 5x. Okay, what's the derivative of 3 to the 5x? Well, it's 3 to the 5x times natural log 3 times the derivative of 5x, which is 5. Now I have to put this all back together. The 2 and the 5 I can multiply and get the number 10. So this is 10 natural log 3 times, these have the same base, so I can actually add their powers. 3 to the 5x times 3 to the 5x is 3 to the 10x. And that's the derivative. So the power rule still applies. Power rule still applies. Okay? What is the derivative? Product rule still applies, of x cubed times 5 to the 3x. Well, this is a product rule problem. So first times the derivative of the last. So x cubed times the derivative, so this is 5 to the 3x, times natural log 5 times 3, plus the last times the derivative of the first. 3x squared times 5 to the 3x. Now let's write this all out. This part becomes 3x cubed natural log 5 times 5 to the 3x plus 3x squared times 5 to the 3x. And I can leave it just like that. So the product rule still works. The power rule still works. And where am I going next? Quotient rule still works. Okay? The derivative of 5 to the 2x over the natural log of x. Oh, now we're going to mix them. You are becoming very powerful people. You are learning the language of the universe in which God has written and encoded things in the universe. That sounds very high and mighty, but you are learning mathematics, which is the language of how God has assembled things. By the way, it doesn't, Tori, just because we learn math and we can learn how to communicate through the physical sciences, that by no means at all explains who God is, which is a fundamental error that many scientists today make. They think they can understand God through the sciences. Can't happen. The Bible even says it can't happen. Okay? We only understand God through His Word and through Jesus Christ and through knowing Him. But nevertheless, you're learning the calculus now, and we're going to figure out how to differentiate this. So what rule do we use? Quotient rule. So low d high. So this is equal to natural log of x times. Somebody tell me what the derivative of high is.
5 to the 2x.
5 to the 2x.
Times natural log of 5 times 2.
Times 2. Minus high. Times d low. What's d low? 1 over x. You guys are experts now. All over low, low. And I'm going to write it like this. Log squared, natural log squared of x. And there we go. And there's the derivative. Okay? All right, Cody. What is the derivative of e to the x?
So e to the x times natural log d
Natural log e.
times 1.
Times 1.
And then, so just be, yeah.
It's just e to the... Wait a minute. So we get e to the x. What's the derivative of e to the x? E to the x. That's beautiful. That is absolutely gorgeous. Because when you take the derivative of the function, you get the exact same function all over again. So just like natural logarithm was the best logarithm to take the derivative of, e to the x is the best exponential to take the derivative of because the natural log of e is 1. There it is. All right? So what is the derivative of e to the 3x plus 2? Well, e to the 3x plus 2, do I have to write natural log e? No. So what's the derivative of 3x plus 2? 3. So I'll put the 3 there. Derivative of e to the negative 2x squared is e to the negative 2x squared. I don't need the natural log of e now, so I'll just take the derivative of negative 2x squared, and I'll get negative 4x right there. And there's the derivative. Does that make sense? That makes sense? So now, Yvonne, you can take the derivative of any exponential function in the universe. Any exponential function in the universe. Try this one. The derivative of the natural logarithm of x divided by e to the x. I'm going to give you a couple minutes, see if you can differentiate that for me. What rule do we have to use? Quotient rule. So what's the first part? E to the x times 1 over x, natural log of x, e to the x. Correct, e to the x squared. Can I rewrite e to the x squared as e to the 2x? Yes, I can do that. So if I was to simplify this, Cody, what I would do is I would actually factor out an e to the x, leaving me with 1 over x minus natural log x over e to the 2x. And do you see that this part here with this part here reduces down back to e to the x again? So my final answer is 1 over x minus natural log x all over e to the x again. Because e to the x over e to the 2x is equal to 1 over e to the x. That's why that reduces to that. And there we go. How are we doing? So far, so good? Okay. There's a story of a math professor, and he was completely, utterly insane. I mean, this guy was batty. And the university could not fire him because he had tenure. And he'd go around the campus, walking up to people who weren't aware of him, and he'd go, "I differentiate you." I mean, this guy was nuts, okay? And people would go, "Ah!" and they'd run away, just terrified. Because if someone walks up to you, their hair's not well kept, and they're just, "I differentiate you." What are you doing, right? So one day, this guy walks up to a bench, and he sees this old gentleman sitting on a bench, and he goes, "I differentiate you." And the guy is he sits there, nothing, no fear, nothing. "I differentiate you." Nothing. Finally, the math professor's just so angry. "Don't you get it? I differentiate you." The man on the bench simply looks at him, lowers his glasses, and says, "Sir, I am e to the x." Okay, that's a lame math joke. But oh, it's a joke. Okay, we'll laugh at that. No, but that's the idea. Okay? Okay. So now you can differentiate these. Yes, you can. So I want you to go back. Numbers 1 through 29, odd. Numbers 1 through 29, odd, this weekend. And what we're going to do is on Monday next week, I'm going to have a review set up for you. The test on Tuesday is 2.1, 2.2. We skip 2.3. We go straight to 2.4. So I want you to know how to differentiate exponential and logarithmic functions. Any questions or concerns? Okay. All right. God bless you, wherever you are today.